Hi everyone. What I'm going to do today is to talk about duality from a more metaphysical point of view, as what you had during this week, I guess. One question I want to ask first to start is this question: what's the nature of space and time? Is it a substance? Are those two different substances? Are those collections of relations between material objects? Is our space and time a priori, as a mind independent of other in the world? So with relativistic physics, we learn to think of space and time as abstraction from a more fundamental unified entity, namely space-time. But we have also learned that it is difficult to separate clearly between space-time on the one hand and matter on the other hand. Indeed, the intuitive game is now played with three kinds of entities: the manifold, the metric field, and the matter fields, added to the context of general relativity. And so you have roughly two debates, one about the relation between the manifold and the metric field, about the reality of points. You have another debate about the relation between the metric field and the matter fields. But I think that with string theory, it seems that we have to go even further in blurring the distinction between space-time and matter fields. And it's what I want to present today. So duality is at the heart of string theory since the second superstring revolution, roughly in the middle of the 90s. And what we have now are five superstring theories and the supersymmetric theory of gravitation. And it's quite common, as Sébastien de Haro explained, to see them as hints at a more fundamental framework, M-theory. Duality is quite technical, so most of the time it's discussed by people that are really highly trained in physics. And so we're aiming at connecting this work with a more general literature in philosophy remain quite well, especially with the literature in metaphysics. And I think it's regrettable, as the existence of these dualities has a potential to impact some traditional disputes in metaphysics, especially about the nature of space-time, but basically about all the fundamental categories of reality that we usually use to think of the fundamental nature of reality, of the physical world. So what I propose to do today is to look at several ontological interpretations of duality and ask what are the implications for the metaphysics of space-time. What I will do first is to present a few dualities and a few facts that are relevant for metaphysical investigation. I will examine a number of ontological interpretations. Again, the background of the classification, I worked on with James Reed in the past. So we did this classification to think of the problem of underdetermination of theories by evidence. But I think that it's also well tailored to think about the different ways the world could be according to the context of the existence of those duality relations. So yes, what I said, basically I will outline some possible consequences of each approach on the metaphysics of space. Before starting, perhaps I want to talk about the status of metaphysics and why we should care about it or not. Because I think both physicists and philosophers of physics are quite split on this question, on the value of metaphysics. So I want to perhaps say a few things to explain how those sorts of metaphysical questions could be interesting depending on how you perceive the value of metaphysics, right? So first thing to say is that one could be either a realist or an anti-realist about metaphysical questions, right? So if you are a realist, if you really think there are interesting questions to ask about, for instance, what's the category of space, then of course those questions are interesting in their own right, and their answers are intrinsically valuable. But if you are anti-realist about metaphysics and you think, well, it doesn't not really interesting. I still think that questions remain interesting in their own rights, but because those debates have an extrinsic value. Indeed, think of mathematical understanding, right? Mathematical understanding is basically use pieces of mathematics to understand something. But if we want to have a physical understanding of something, we must go beyond, right? So here you can think of Maudelin's distinction between the formalism and the ontology. I guess also for the people who were at Sébastien Desharreau's presentation yesterday, all this discussion about the role of visualization in understanding is also an instance of going beyond the mathematics to understand the world. So in order to understand something, it's not enough to just use the formal tools. We also have to interpret those tools and try to understand how the world is according to those tools. So visual understanding can be something. I will argue that ontological clarification is another tool actually to understand the situation. But then perhaps you could even be more radical in being anti-realist about this question by saying, well, look, I'm not only anti-realist about metaphysical questions, but I'm also anti-realist about theoretical entities in physics in general, right? But then again, I want to say, well, look, even if you're right, even if you are right that instrumentalism is the right way to go, I still think that ontologies can be used as tools of understanding, right? So even if you're a radical anti-realist about everything, I think having a clear classification of various ontologies available can help to perhaps navigate a bit all the texts, all the ideas that we find in the literature, especially about duality. Right, so first let's introduce string theories. What I'm going to do is to introduce a naive picture and then introduce a few complexities. So according to string theory, the world is fundamentally made of 10 or 11 dimensions, populated by one-dimensional entities vibrating with various frequencies, giving rise to what we take to be the elementary particles of the standard model of particle physics. So this picture is naive first because it's a classical description and because the background space-time seems to be emergent or unreal. So here I want to be vague on purpose about what it means for something to be emergent and whether emergent entities are real or not. Yeah. Very roughly two different traditions about the ontological status of emergent entities. And second, you have the relations of duality between seemingly mutually inconsistent descriptions that shed doubt on the series ontologies, on the ontologies suggested by all the theories. Something quite important, I mean, it's my understanding that something quite important is the worldsheet ontology, at least at the classical level, before we quantize. All the perturbative superstring series, so the 5 superstring series, they rely on 10-dimensional background spacetimes, right? So I took this little picture from Nick Huggett and Christian Wetter's chapter here. So on the left here, it's a representation of the background spacetime. So usually has 10 dimensions. X0 to X9. And here you have the world sheet. So here you have this that basically has a trajectory in the background spacetime. And so in the embedding background spacetime, we have this two-dimensional world sheet. But it's quite usual, many people insist in the literature that the 10-dimensional spacetime that are embedding the strings can be viewed as emergent in a relational spirit. So here I use the word relational spirit in reference to the classical debate between Leibniz and Newton about the status of space and time. Are those substances, or let's say absolute entities, or are just a name for collections of relations between things? And in a way, we can think of the worldsheet ontology as a relations approach to take natural entities to exist first, with the geometry arising in the second stage only. So Francis David Baker has interesting work on this. So the idea is that we could basically reify the worldsheet ontology and think of the background space time as a target space, so as something that emerges. So basically as scalar fields that are defined on the worldsheet. So naively, we could say, well, so the target space is just a physical space, but many people, like Nick Huggett especially, have argued that no, we should not think that target space is space. Namely, we should not think that this target space corresponds to the real physical space-time that we observe around us, or that we say where we make measurements with rods and curves. So, second thing to say is that so we have 5 superstring theories, I would say, that are related in a web of duality relations, and we have symmetries between whole spaces of solutions. So as a first look, we can mention T-duality, right? Very roughly, very naively, if you don't know that, the idea is that models of the theories describe worlds with different sizes, different compactifications, radius for some of the dimensions involved, but nonetheless, they seem to be equivalent. And if we zoom out, what we want to do is to relate the network of dual series to a more fundamental non-perturbative M theory, at least if you accept that M theory is the more fundamental theory we are looking for, or to another framework, but also, of course, to general relativistic spacetime. So it's like we have this 3 levels picture, right? We have the fundamental theory, we have the 5 superstring theories, and then we have the standard model and general relativity.
Could you just quick clarification? I think in the model theory jargon, there's a word categoricity. Is that a word in the model theory jargon?
Category, is it?
Categoricity.
Categoricity?
Yeah, isn't that?
I don't know.
I believe you're saying that the theories and questions are not categorical in that. So different. Well, anyway, if you don't know what the word means, I guess I can't.
Yeah, I'm sorry.
I can't ask the question. I think that's the word, but I'm not sure. When the models aren't isomorphic.
Okay. I don't know.
I'll look it up.
Thanks.
Sorry.
So it's not clear what's the metaphysical status of the duality between the 5 theory, as long as we don't have a fully worked out M theory, right? So I think that in order to really know what's going on, we have to wait for the next physics, or the next evolutions in the paradigm. So I would say more on this. But at this stage, what I want to insist on is that we cannot naively take the spaces on which the strings live, the so-called target spaces, to be just the general relativistic spacetime. So according to one understanding of duality, the most probably the most popular one, the common core approach, M theory or another more fundamental theory will be based on the structure common to all dual theories. So there are subtleties here, and there are different subversions I'm going to talk about. But perhaps what I want, my understanding is that at the moment there is no agreement that we understand well the mathematical and ontological nature and profile of this common core structure, right? So depending on how liberal we want to be about what counts as a mathematical common core, we might say or no that we have it. But if we also want to have a clear commentary in modeling sense of how the world is according to the common core, it doesn't seem that we have that at the moment. Right, so very quickly on T-duality, I will not just say a few more things about the dualities that, I mean, those of you that were here during the whole semester will have a pretty good idea about what I mean, but just for the presentation to be self-contained, I will just mention a few things here, right? So take a toy model of the 26-dimensional bosonic string theory. You can think of it as having the geometry of a 25-dimensional inclusive spacetime with one of the spatial dimensions from a cycle of radius 4. And the idea is that the empirical substructure of two theories, T1 and T2, can be indiscernible by exchanging the winding number and the momentum number, and exchanging the radii of the target space and the radii of the winding space. So here I quote the quote from Becker and al., which is one of the string theory textbooks. It suggests that compactification on the cycle of radius R is physically equivalent to compactification on the cycle of radius tilde. So what exactly is a suggested ontology here? It seems that it's quite a difficult topic because there are not that many philosophers of duality, and they all seem to have slightly different ways to understand what's going on. So here I'm just going to present two. So Nick Huggett, for instance, think of the situation in terms of permitting physical space and a winding space, a space that will measure the way strings winds. And in this approach, it seems that duality will concern the whole of the target space and not just the compactified dimensions. And if that's the case, it seems to suggest the non-fundamentality of the whole target space. Right, so here is the picture that Nick Huggett used to illustrate his way of looking at the situation. So just look at the upper part of the picture. So we have theory 1, which represents what he calls physical space, but with a grain of salt, because yeah, the argument is trying to show that we should worry about this physical space being really a physical space, but let's call it the physical space with radius 4. And we have another space where you have a measurement of the winding of the strings. And then you have a second theory where you permute different things, right? So you will permute the radius of the two spaces with this factor here, and you also change the wave function, right? So you have one here, one here. So I'm not sure exactly how to understand the details of Nick's picture. I mean, I'm still talking with him and trying to understand the details. It's quite complicated. But I know that it's if you look at the book by Tiziana Vistarini, which is I think a very nice book for people who don't have a strong background in physics. She offers a quite different picture. She says that the duality concerns the compactified dimensions only and not the big dimensions. And this seems to suggest a non-fundamentality of the compactified dimensions only. And here I also mentioned a paper by Matsubara and Johansson, where they kind of did the same, also with a focus on mirror symmetry, that what's emergent or unreal would just be the compactified dimensions and not the macroscopic dimensions. Right, so mirror symmetry is a generalization from T-duality, in the sense that the compactified spaces can have different topologies. And it's where it's also where Keizo Matsubaro and Nelson say that we may find a temptation here to take this as signal in the compactified spaces or internal spaces, just as it's usual in other contexts in quantum field theory. So my impression is that if we zoom out and we are just operating at a level of description where we are interested by metaphysical implications, the situation is quite similar with T-duality and mirror symmetry. Right, and finally, so I won't talk about S-duality, but I will say a few things about the gauge gravity duality. So here, as probably know now, the idea is that you can have a gravitational series n+1 dimensions that are fully equivalent to non-gravitational quantum field series with n dimensions. Right, so suggested by black hole statistical mechanics that the number of microstates of a black hole seems to be proportional to the event horizon surface rather than to the bulk volume. And so it suggests that we can use a conformal quantum field theory on the boundary of a volume of a higher dimensional space-time, which is described by string theory. Right? So what's super interesting is that you can describe with a quantum field theory in an equivalent way the gravitational theory, and you can try to apply that to black holes. And so the ideal CST correspondence is the most famous instance of gauge gravity correspondence. So the two expressions are sometimes used. And the idea is that we have a duality between a theory that describes a world with gravity on ideal spacetime and the conformal field theory that lives on its lower dimensional boundary, a four-dimensional Minkowski spacetime without gravity. So the famous example is the duality between type 2B string theory and the Yang-Mills supersymmetric theory. And the intuitive picture, how you do that is that you take your 10-dimensional space-time, right, of string theory, and you factor it into space, right? So you have your let's say your kind of regular space that has 5 dimensions, and then you have another space, like an internal space of 5 dimensions. And then the idea is that the conformal field theory describes a 4-dimensional space-time that corresponds to the boundary of the IS5 space-time. And then the S5 structure will correspond to internal degrees of freedom on the CFT side, when the 5th dimension of the bulk space, so the AS5, will correspond to an energy parameter on the CFT side. Right, so there the idea is that the boundary, the properties, the dynamical properties of the theory on the boundary will encode both the extra radial dimension of the bulk space and also the compact extra dimension S5 at each point of the bulk AS5. At least it's how I managed to understand the situation. Happy to stand corrected if mistaken. So here is a quote from Tiziana Vistalini, where she says, "This correspondence is the most concrete scenario in which some spatial dimensions of some bulk spacetime arise from dynamics occurring on this distant boundary. The spatial dimensions are encoded in the boundary as internal degrees of freedom of quantum fields." So now I want to make a few observations already about the situation, because there are different claims, sometimes opening to the notion of emergence, as Sebastian Bearo explained yesterday. So one thing I want to say is that this duality is not purely in terms of stringy structures, but involves a non-stringy theory. Right? So if we accept the physical equivalence of the two dual descriptions, then it seems that it points towards the non-fundamentality of superstring series, right? We should perhaps not take them too much at face value regarding their ontologies. So here is how Tiziano Vistarini, sorry, is the point. Differently from T-duality, the non-fundamentality of space-time here also points to the non-fundamentality of quantum string theory itself in virtue of its physical equivalence to a quantum field theory not containing strings. Right, so here I think there are two possible options, at least logically, right? But looking at what is suggested by the physics itself, right? We can ask, is there a kind of equal fundamentality between the two sides of the dual relation? That would be interesting, but that doesn't sound appealing from the physics. Sorry, the slide is not clear. What I was willing to say that doesn't seem appealing to, from the physics point of view, to privilege one side, right? So it's more like we are. It seems appealing to think that there is a kind of equal fundamentality between the two descriptions. And so the holographic ID is a bit ambiguous because depending on how you read the claim, you can either mean that the CFT side is more fundamental and the bulk side will be a hologram, namely a representation involving a fictitious extra dimension. So I guess that would be a kind of literal reading of the holographic ID. And also some physicists using the talk of emergence to say that the bulk emerges from the boundary is kind of misleading in this way, as I explained yesterday. So I don't think we should accept this holographic ID if you take it to be asymmetric in this way. Right, and many people, many philosophers of duality and physicists also are arguing that there is no reason to privilege one side over the other, right? So, I think we should not take the ADS CFT correspondence to show that there is a kind of really ontological emergence, that's a real kind of holographic emergence. Right, so the second option, which is more appealing, is the idea that both sides of the duality emerge from a third, more fundamental structure. Right, so probably there will be an underlying ontology of states or of strings and brains, right, to be described by a more fundamental framework. So it's still consistent with the idea that the CFT side is less perspicuous, I think, in terms of ontological categories, because there is no mention of strings, right? So yeah, I wonder whether we should not, perhaps we should understand this situation as a situation of equal fundamentality in terms of description, even though the ontological categories involved on one side could be more faithful to the real fundamental nature of reality, right? And here by ontological category, I mean the strings or brains. So what's now let's zoom out and talk a bit more about the ontology of duality. So what's a relation of duality? So a lot of attention has been given on this question, especially from a formal point of view. And the main topic has been about whether the duality-related series are physically equivalent, namely describing the same physics. Right. So actually, physicists, string series were using this expression of physical equivalence. And so then it was a question whether they are right to say that, and how we should understand this idea of physical equivalence. So could we pursue a different line of thought? I think that, well, no, they are not really physically equivalent. They are description of different physical situations of worlds. So my understanding is that the situation is to right now to think of them still as being physically equivalent, even though Jeremy Butterfield argues in the other direction that they are not physically equivalent, and it helps to analyze the situation, not to cause it from the start, but they are physically equivalent. And so on this question, I mean, and Sebastian Leao and other people like Jeremy Butterfield did a lot of work to try to clarify what's going on. And most of you heard about his scheme, and I think it's impressive machinery to explain a bit how we should understand the notion of duality in relation to physical equivalence. But I also think that all this discussion try to steer away from ontological questions, which are the questions I'm interested at. So I want to say a few more things to try to suggest some ideas about how to understand how the world is according to those formal frameworks used to analyze duality. Right, so there could be, I guess, two different projects. One would be to advance the understanding of dualities through formal tools, for instance, with the development of mathematical results, or by reclasting those equivalences in terms of category theory, for instance, or this kind of approaches. But I'm more interested in another approach, as you guess now, is to try to look at different ways to understand the ontology of the world. Yeah, so that's why. So I'm not saying that what I'm interested at or doing is an alternative to the formal approach. Not at all. I think what I'm trying to do is to offer a complement a bit to gain some more insights about how the world is. So it's more my modest attempt to try to add some ideas about the ontology of the world according to duality in all the formal framework we can propose. Right. So now what I'm going to do is to describe different approaches to duality, general approaches of the ontology of duality, and sketch out some of the implications. Right, so as I said, the most common approach is probably the common core strategy, which is to extract the mathematical and ontological common core of the dual theories. By mathematical common core, I mean a formal description, perhaps in standard mathematics, or using another formal, other formal frameworks like category theory. And by ontological common core, I mean something more visual, I guess, a description of what the world is like and made of according to the mathematical common core, right? So, like what Maudlin calls the commentary of the theory. In the paper, actually, with James, we discussed another egalitarian strategy in the article that we call the overarching theory. But here I will group the two together, the two approaches for discussion. So the difference is that the common core tried to really find the overlap of the two theories to know exactly the domain of entities to which we should be committed. When the overarching theory is more the idea that there is another theory from which you can recover as approximations the dual theories, right? So you need a third more fundamental theories that will be used to explain what's going on. So I think that the most appealing and reasonable strategy based on the common core of the overarching theory, if you look at what the physicists are doing. But I think there is no guarantee actually that there is a common core, like really an ontological common core, a clean picture of how the world is. As I said before, perhaps for the mathematical common core, perhaps we can guarantee its existence if we are ready to be super liberal, like I don't know, with classes of equivalent fact, and we say, well, look, the common core actually is a class of equivalent mathematical fact, something like that, or why not? But at least for the ontological common core, I'm not. I don't see what it is actually for me. So I would say that the common core approach is a default position, rightly so. I think it's a guiding hypothesis string theory that's a very powerful guiding principle in the search of new physics. So we should try to use the dual series and try to use them to find something new. But at the same time, I don't think there is a logical guarantee that it will work and that's the right path. So maybe it's how I combine my belief that the scheme that Sébastien de Haro proposes is the best, the most promising way to go with cautionary note of James Reed and modernism. Right, so what are the metaphysical implications if that's the right way to go? Well, we will have the emergence of space-time string theory, because although the theories are formulated in terms of relativistic spacetimes, those are not part of the fundamental ontology. So T-duality thus suggests that there is no fundamental space-time, and perhaps only an emerging one, right? With the idea CFT, I guess the take-home message is a bit the same, right? We start to doubt about the existence of a specific number of dimensions. Maybe those are some kind of artifacts related to the use of a particular mathematical theory. All right, so another approach that is usually dismissed, but I want to talk about it, is a more discriminatory strategy, which will be to say, well, look, we should actually privilege the ontological claims of just one of the two dual theories. That is, take two dual theories, T1 and T2, right? That with respectively solutions M1 and M2 related by the duality map. Naively interpreted, we could say that M1 and M2 represent two distinct worlds, respectively world 1 and world 2. Here, I don't really need to say what kind of modality I'm using, right? So it could be epistemic modality or physical modality, but let's set this aside. I don't think it's important here. But it seems that we have a case of underdetermination. And as we argued in the paper, usually we don't like underdetermination. We want to break situations of underdetermination. And we can perhaps just stipulate it, like say, well, look, they seem to be, there is some equivalence between the two frameworks, but let's just say that one of the two is a legitimate description of the actual world, or at least is better at it than the dual description. Right? So nothing wrong with stipulating something like this. And that will imply that dual theories are not physically equivalent, but James Butterfield argued for this, and I think in a way, at the end of the day, it's more a matter of intuition, whether we want to enforce from the start or not, that they are physically equivalent or not.
What do you think force? What do you think from the start?
If we want to enforce, if we want to impose from the start that they are the same or not, I don't see a principal reason to condemn one of the two paths. But of course, it seems a bit weird if we don't have a principal reason to favor one side of the duality, right? And if we are in situations where we don't have any reason to favor one side of the duality, that seems to be an issue. For instance, of the ADS CFT correspondence, the different status of fundamentality might suggest that the 2B side is ontologically more perspective than the CFT side, right? So maybe you could find still, some other reasons to that are external to the theory to break the symmetry, the apparent symmetry of the fundamentality of the two dual theories. But for the DSCFT, corresponding pairs are more odd to find a symmetry like this. But for the other duality, it seems more problematic because even if one follows Butterfield in arguing that the theories describe different situations, there will be no reason to favor one description over the other. Why should we favor, for instance, type 2A to type 2B? But that's one way to go to find some kind of, I don't know, meta-empirical reason to say that one theory has some virtue that is missing on the other side. But now I want to add a few more comments, perhaps to blur the distinction between the common core strategy and the discrimination strategy. So perhaps what we should do is to just wait and see, right? For example, if the superstring series are not fundamental, but the M theory is, or I mean, here I don't mean to say that M theory will be absolutely fundamental, but at least assuming that M theory can be fully completed and will be more fundamental than all the other theories, perhaps an explanation could be provided in the future using empirical resources for the existence of the dualities between the five superstring theories or and also for the sort of effective duality Sebastian mentioned yesterday. For instance, Matsubara and Johansson argue for a discriminatory strategy that is also a common core approach. So it's something I realized is, by talking a lot to Keizo Matsubara. It was insisting that even though the dual theory had a mathematical common core which correspond to the fundamental ontology. So even if you accept that, you could still think that one of the two sides of the duality relation is closer to the phenomenal space-time than to what Rosenkreuz measured. Right? So the picture is like this. So you have the five superstring series, then you have the more effective description in terms of generativity. The idea is that, okay, you could analyze what's going on at the level of the five superstring series, say, well, look, we should not discriminate at this level, but nonetheless, we can see that one of the representations, one sort of representation at the fundamental level resembles more to the effective space-time of generativity, to the phenomenal space-time. So that would be one reason to say that even though we are pursuing a common core or overarching approach to at the level of the superstring series, we could still find these kind of reasons to break the symmetry, to break the equality of fundamentality and to say that one side is more ontologically perspicuous, right? It's a better representation of the emergent space. So what should be the situation? Well, I think the situation is roughly similar to many cases in the field of physics, where very often explanations in physics work by waiting for a successor theory to explain the puzzle that was present in the previous theory. Right? Think, for instance, about the identity of inertial, or I should say proportionality, suggestive of an identity between inertial and gravitational masses in Newtonian physics. It was explained later in general relativity. So you can explain it both intuitively, like using visual understanding, with the idea of the curvature of space-time, and you can also explain it mathematically, rigorously, with derivations and theorems. So perhaps we need the next theory to get an intertheoretical explanation. That's what's required. And perhaps this intertheoretical explanation will break the appearance of equal fundamentality. Cool. Seems logically possible. An advantage if this happens that duality will turn out to be a bit business as usual, right? Classical case of determination of theories by evidence. So if that's the case, what are the metaphysical consequences? Well, as I said, it's business as usual. What really matters here at the end of the day depends on whether the duality-related theories are absolutely fundamental or not, namely final theories of everything. So of course, in the case of the 5 superstring theories, the expectation is that those are not absolutely fundamental, right? That what should be absolutely fundamental is another framework like M theory. But who knows? I mean, that still seems like a logical possibility that those dual theories are something close enough to them will be final, or who knows? Maybe we are going to find a new web of dual theories that will be more fundamental than the actual web of dual theories that we have at the moment. Right, so I think it's worth thinking about this. But what's important is that if there is no more fundamental theory, right? So if we have a kind of, if we want to pursue a discriminatory approach, and we think that the 5 superstring theories are absolutely fundamental, there won't be anything fully satisfying that it's more fundamental. Then we must accept the existence of brute facts to favor one individuals. It's not appealing, of course, but brute facts, because brute facts are to be avoided. And I just want to say a few things about the epistemological status of this idea that we should avoid brute facts that have no explanation, right? So to do that, I think it's nice. It's nice to just use the good old Leibniz and this principle of sufficient reason. Right? As you may know, the principle of sufficient reason states that everything must have an explanation. And of course, a brute fact is exactly a lack of explanation, right? It's a fact that has no explanation. And I think if you think that we have a situation of duality between absolutely fundamental theories, and your putting one is a better description of the world than the other, then basically what you are doing is to put into brute fact that violates the principle of sufficient reason. But the thing is, I think the principle of sufficient reason is question begging, because it will never be possible to know whether reality satisfies the principle of sufficient reason. And if it doesn't satisfy this principle, where to stop the quest for explanation? Something I always a bit complaining about is that, in metaphysics, not in philosophy of physics, but in metaphysics, it's very common for people to be what I call rationalists, which I'm using the label in different ways than the usual way to use this label. But rationalism, as defined it, is the view that the reason, so the ability of our mind, is absolutely powerful and can, in principle, explains everything about the most generic aspect of the world, right? So it's quite healthy to be rationalist and to try to explain as much as we can. But I think if you are moved by empiricist or naturalistic motivations, you should concede that there is no guarantee that the world is like that. That the world has a transparent structure that we can describe, connect to with our mind, right? So perhaps there is nothing like that, and what we can just do is to use some mathematical theories, build some ontological models, or use some kind of visual understanding, but in fact there is no fundamental structure on which to plug, right? So if that's the case, perhaps the principle of sufficient reason is false. So just to conclude on this, I think the principles remains an excellent guiding principle for theory building, but there is no guarantee, again, that it's a metaphysical principle, right? So in theory, that could be the case. I see no impossibility for a situation like this, a situation where you have a web of duality, which has perfectly physically equivalent, and still out of reach of our knowledge, one of the sides is more perspicuous. That could happen, but of course there will be like a position that we should only accept at the end of scientific inquiry if we were not able to use the duality in a heuristic way to find new physics. I just want to finish the talk. I just want to mention two other possible approach about the ontology behind duality. So of course there is an option that we don't want to consider when we think about string theory, but still I think we should consider it. There is still an option that the dual series are not being final series, that their solution actually cannot be understood as representing possible world, or only as redundant description. To make sense of this, consider, for instance, solutions of Newtonian mechanics, right, which is an uncontroversial case of a non-final theory. The stability of matter cannot be accounted for in this theory. For this, we must proceed to some quantum mechanical successor, right? Because in classical physics, matter should collapse on itself, right? Because the gravitational force rise when the distance between two elements goes to zero. So one may be a nihilist also about the ontological claims of any non-final dual theory, while still remaining scientific realist, right? So there is one option to say, well, look, I'm not interested yet at, I think it's premature to do metaphysics in the context of string theory, because we just have to wait for absolutely fundamental theory and look at the ontological commitments of the theory. But before that, we should not really care about this.
Just one clarification, could you clarify a bit more what you mean by kind of, would you mean what people know in all theory of everything, so that it becomes all observations, or rather the endpoint of a given succession of theories?
Same question.
So can you clarify? So one notion is final. So by absolutely final theory, I mean something like the end of the chain of possible theories. And then this. I mean, I guess what you are saying that this absolutely final theory could still have a restricted domain of application. So it would not be a theory of all phenomena. That's what you meant?
Yeah, that's the distinction I was making. Whether you are, I mean, they could also go together. But
yeah,
I was wondering whether you have the more encompassing notion or the more restricted one.
I mean, here I think it could be a nihilist for various reasons. So first, you could think that there is a final theory of everything, and that we need this final theory of everything, like the rich theory of everything, and we need to have that in order to be justified in accepting the ontological commitments of the theory. But I guess you could say the same for a final theory which is not a theory of everything. Perhaps you could have a picture where you accept that there are different theories applying to different domains, and you could say, well, look, I think that in order to accept the ontological commitment of a theory, it doesn't have to be a theory of everything, but it has to be a final theory. I think you could have yeah, you could be nihilist for those two reasons. And, yeah. Personally, I don't have a view on this, but it's different reason why one could think that. Right. If that's the case, well, nihilism implies that duality tells nothing about the nature of reality. And I'm sorry, it's my attempt to make a joke, but it's very difficult for me. Right. So, and also, of course, something I didn't mention, it will also be an element of loop quantum gravity or any alternative to string theory, and have principal reasons to worry about duality. That will also be a reason to stop running any ontological inference. And to finish, I want to mention the pluralist strategy, which was kind of a sort of borrowed idea that we present at the end of the paper. I don't think it's very promising or interesting in its own right, but it's interesting to see some common assumptions we made generally in quantum gravity about what we are trying to find. And the pluralist idea is that duality-related theories could reflect the existence of dual physical structures, like really distinct structures, numerically distinct physical structures. And so in this picture, the idea is that the distinct structure of each of the dual solutions under consideration describe co-instantiated structures in the actual world. So that is, on this view, dual solution may be taken to represent parts of one world. Right? If you take, for instance, the ADS-TFT correspondence, the idea would be like, okay, the two series that are physically equivalent, if in fact, even though they are physically equivalent, each represents a distinct structure that are phenomenologically indistinguishable. So each dual described in this picture as a different reality, but each of the structure under consideration represents a numerically distinct part of one world. So according to this idea, the physical world would be in a certain sense fundamentally fragmented. So it would be a collection of distinct structures that we cannot distinguish between. To perhaps try to make sense of this, think of an analogy with the landscape multiverse move. By this I mean like the motivation to move from a landscape of solutions to an ontology with many universes that we call the string landscape. Sorry, the string multiverse, to distinguish from the string landscape. And one way to translate many solutions in general into one unique solution is to claim that the models composing the space of solution, the model space, are in fact parts of a unique solution. Right? So you take your whole space of solutions and say, okay, I'm going to, by the power of the mind, I'm going to glue together all the solutions into one maximal solution. So you push the class of models into one particular larger model. And if you do that, well, of course, the broader model fails to be even simply connected, which is generally an assumption in physics, because it wasn't that it's a fragmented manifold, right? It's really a collection of disconnected manifolds, right? So what you are trying to do is to think of the world as being described by a mathematical solution that represent, by a mathematical model which is itself made of disconnected solutions, disconnected manifolds. Of course, here the analogy is very partial because with duality, the fragments of reality would encode the same manifest world when with the landscape of solutions. The idea that all the solutions are different, so it seems less metaphysically demanding to accept this kind of strange multiverse than to accept this strange collection of structures that are indistinguishable in any world. Right. So, what would be potential advantage of this super strange approach? Well, that's something like reading directly the ontology in a plurality of equivalent theories. So, well, look, if there exists a multiplicity of theories, well, then we learn there is a plurality of ontic structures described by those theories. Of course, I don't think it's super convincing. It seems a bit like being a bit naive about the superficial structure of all theories, but maybe something one could review for. But as I said, I think it's even if you don't like it and you think it's too strange to be interesting, at least it questions central assumption in scientific inquiry, which is that the universe admits of a unique fundamental structure, right? And one possible way to read the existence of dual relations could be that in fact this assumption is wrong, and that there is no unique structure in the world, and the world in fact is a multiplicity of structures, and we can take one or we can describe one or another, and that might be a way to explain why we are so surprised about those duality relations. So, but what are the issues? Well, of course, the first issue is that it's a weird fragmentation of reality of distinct structures that coexist. But the idea is not completely absurd, at least I think. It's weird, but not inconsistent, I think. It's a process of Kit finds fragmented time, where he has this kind of idea to analyze the structure of time in terms of contradictory instants of time that coexist in a way, and giving a very rigorous explanation. So I'm not a big fan of this idea, but I'm just willing to mention that the idea that reality could be fragmented is not completely, it's not standard, it's not common, but still you have many scholars in philosophy developing this sort of ideas. Mathematically, I think there is no problem to consider fragmented manifolds, but it goes a bit against practice in physics, right? To use manifolds as having some properties like being unified manifold without poles, I think simply connected. So if you are going to completely fragment your manifold, it seems to go against the practice. I think perhaps the most powerful way to show that this approach is pragmatic is to, at least in the context of the paper where we are talking about underdetermination, I think it's fair to say that if you go pluralist, you are just trading a problem of underdetermination for a problem of overdetermination, right? Because you were trying to say, well, look, we have two different descriptions that are equivalent. How are we going to choose one? And as you say, both are real, so you solve the problem of underdetermination. But now you have a problem of overdetermination, because it seems that one would be enough to trigger the phenomenal world in which we live, right? So yeah, that's a new problem of overdetermination. All right, so to conclude, I think the metaphysics of space-time in string theory is a difficult matter, because there are many ways to understand duality. The attractive and popular common core approach suggests that space-time may not be fundamental. There are many ways to build arguments of this sort, but perhaps it can still be consistent with space-time being fundamental. Right? Here I'm thinking about Matsubara Johnson's idea that well, perhaps we'll discover that one particular model is a better representation of the phenomenal space-time in which we live, that we measure with watch and clock. And thus, this representation will still be four-dimensional, seems to be possible. Other approaches carry other metaphysical implications, but they are less perhaps important because they rely on those other approaches that are less promising than the common core approach. If string theory is on the right track, its potential impact on the metaphysical space and time is high. I think it's very promising to better understand the nature of space and time. And in a way, I think that we need a more fundamental theory to make progress with our understanding of the metaphysical nature of space and time. String theory is the most promising candidate. But at present, when we try to read the ontology in what we have, I think it's fair to say that we know little about the fundamental ontology of space and matter. If I were to bet, I would say, well, we can bet that the sharp distinction between fundamental space on the one hand and fundamental matter field on the other hand will not survive in string theory. Right? So, yeah, on this I will stop. Thank you very much.
Thanks a lot, Baptiste, for the next talk. So we have roughly 20 minutes for questions, and since we have more of a structured talk today, the idea is to have maybe a little bit more structured Q&A. So if you are online, you can write Q in the chat if you have a question, and then if you have a follow-up, and kind of the same works here in person, that you can raise your hand if you have a question, and if there's a follow-up. So
There is someone online.
okay, so Pedro has a question. Pedro?
Yeah, thanks, Enrico. Thanks, Baptiste. Yeah, okay, just clarification regarding sorry, well, I pretty much agree with your overview, because it's fair to say that so far it's to a great extent a matter of taste which sort of approach you take on dualities in this context. So, but yeah, I was just a bit puzzled by the last stance, this pluralist approach, because unless I misunderstood, I mean, with these lectures, I mean, Professor Johann Edmenger has been very clear in basically showing how real processes that are being measured in lab in this gauge gravity duality. For instance, take quark-gluon plasma, one of the examples that she's been giving. Okay, in this case, we have basically a CFT theory that basically describes in low energy limits this quark-gluon plasma in QCD, and then she has shown that basically using the gravity dual, they are able to predict the results that are basically in agreement with the empirical data. So my concern, again, perhaps I missed the tenets of this pluralist approach, that in this case, this fragmentary view of the world. So one might take, okay, let's take that the gravity side is just a mathematical device that allows us basically to make predictions of strongly correlated systems that are very hard in the basically CFT side. Okay, that would be, well, fair enough, let's say, but this is not what this approach thinks. I mean, according to it, if I got it right, both the CFT and the gravity side are ontologically real. So they represent distinct fragmentary visions of the same world. So it's passing for me that basically you can use resources of the gravity side to basically yield results that are empirically corroborated on the CFT side, and then still claim that both are fragmentary visions of basically of the same world. So I don't know if I'm missing something in the statement of the pluralist approach, because according to me, I haven't given much thought, because I just basically I faced basically this pluralist approach in this talk of yours. So, but it seems to me that it's kind of ruled out. I mean, by these empirically corroborated theories, unless you are basically have in mind as not you, I mean, the one that advocates this approach. One, well, I don't know. I mean, so if you basically clarify in this specific example, because I mean it's taken from real lab measurements, so there is no need to basically speculate about wild structures.
Right. I guess the way I think about it, that there are two different levels of description. You have the levels of the ontology, what's going on in the world, and you have the pragmatic level of description, what we can do. I guess one way to answer your question would be to say, well, okay, look, in some contexts, one dual is helpful and not the other. That's why those correspondents are super helpful for physicists, that they can, like, I mean, any strong weak duality helps you when you cannot solve the problem. You can switch to the other description to solve it. So that would be the pragmatic, practical way to use those dualities. But even if for some mathematical reasons, one side is the only side that is useful in a particular context, that doesn't mean that when we move to the ontological level, we should infer from the fact that one side is favored by practical reasons to the claim that it's favored for also at the ontological level, right? So if I misunderstood you, I'm sorry, but if I understood you correctly, I would say that, well, you should not move directly from practical usefulness of some theories to an ontological.
No, but yeah, sorry, because perhaps there is a misunderstanding here. My concern is actually because yeah, I agree what you are saying, but my concern is that there seems to be a sort of clash between the ontological status of both sides of the duality and the fact that they are fragmentary, parts of the same world. That's the issue that I have.
Part of the same way, sorry?
That there seems to me to be a clash between, on one hand, basically that both sides of the duality are ontologically real, so they basically exist, not just mathematical abstractions, and on the other hand, that basically they are fragments of the one and the same world. So those two things seem to me to be in, well, I wouldn't go as far as a contradiction, but it seems to be a strong tension between the two. So that's my concern regarding this. At least, as basically you are basically proposing, sorry, not you, I mean, the way that you're been discussing the proposal as the pluralist approach, but.
Yeah, no, you're right. You're right. It's definitely amounts to it's very close to refine some kind of contradictions. Like it's quite similar to the idea of the fragmented time. Like as I said, it's like you have contradictory instance of time that generates time itself. Here the idea is that you have contradictory structures that compose the universe. Yeah, that's super weird, and I agree with that.
Okay, then I got right, basically the proposal. So basically my concern is well-founded. It seems to be the case, right?
Yeah, it's why I say that it's a weird fragmentation of reality into contradictory fragments. You could put it as it is.
Okay, fair enough. Thanks a lot.
Does anyone have a question here? So that's last, and then if anyone online has a question, please write in the chat.
Unfortunately, during the first part of the Q&A time, I had to go out for my father, 90-year-old. So perhaps I am saying something that has been already said. Already been said. Yes, I would like to know your opinion about this point. In your conclusion, you say that we don't know whether string theory is or not background independent. That is, if space-time is something that emerged from worksheet, or vice versa, it is something that we have to assume. And you proposed the position of Haggett and Misterini, which said that the first one, that is that space-time is something emergent from worksheet because the target space is not space. And so the idea is that it's something physical, and so in a certain sense, space-time is not assumed, it's not background dependent, but many physicists think in a different way. So it is a very strong position from a ontological point of view. I'd like to know your opinion about it. I have in mind two arguments, one favoring the background dependence and one favoring the background independence. And I would like to ask you what you think about this presentation. The strongest argument favoring the background independence seems to me the fact that all observables, all variables in the target space are observables, and this is different from what happened in field theory, where you know that space and time are parameters, and so in a certain sense, it is the different dimension of target space-time are all physical objects in the full sense of the term, and so you could not associate observables with an algebra with particular behavior from an algebraic point of view with what we intend with space and time normally, cost space-time and relativity, spatial in general. This seems to me the strongest argument favoring the background independence. On the other hand, also in the worksheet presentation of string theory, that is the less background dependent, you have that there is a sort of mapping from worksheet to this dimension of the target space. So there is not, one cannot say that the variable of target space is something that is physically built on the basis of worksheet. It's something that we have to assume. So this general geometrical structure seems a presupposition of the theory, and this seems to me the strongest argument favoring the fact that string theory is background dependent. I don't know what to think about this.
I mean, the way I understand things right now is that I will make a distinction between two questions. The first question would be whether the space-time of the first question is the generalistic space-time background independent or not? Answer is yes. But then I will disconnect this from the question about the reality of the target space, because I think that even if you were to if we were to find out with M3 that the target space is real, I think we'll still be consistent with the target space being described as background independent relativistic spacetime. So I guess I distinguish the two questions. So I would not be able to answer you directly the terms you suggested, because I tend to think of those two questions differently, right? First question, is the target space real or not? So we have suspicion it's not real, but even if it were to turn out to be real, because we will learn, I don't know, with M series that there is a natural compactification, something that leads to one phenomenal spacetime. I think probably this phenomenal spacetime would, I don't know. At least I used to think that this phenomenal spacetime would still be background independent.
Do we have time, or I can also ask them?
No,
Yes, first of all, I would like to thank you for the talks. That was very interesting, and I think this kind of physical analysis can be very, very fruitful. In particular, the last 2 years that you gave on nihilism and pluralism fragmentation. I think that was very interesting. Just a question of clarification, whether you could say a bit more about what you mean by this overarching theory, whether it's part of the metaphysical analysis of the dualities, or whether it's rather more of a, what I myself call a successor theory, like a theory that kind of goes beyond the two dual models, and of which the two dual models are approximations. Could you?
Yes. Thanks. Yes, the idea of the overarching theory is that it's a successor theory, and then you have a kind of explanation in terms of the successor theory for the existence of the duality relation in the previous theories. And so I guess you could think of that in terms of limits, but I would not want to impose different a limited number of ways the overarching theory could be connected to the previous series. I guess in a way, when you talked about the heuristic use of effective duality, you could think of this as a kind of exploration for trying to find an overarching theory. So yeah, I think it fits with your with what you call the successor theory, I guess, or at least.
So the relation could also be of specific cases. So it doesn't need to be just the limit.
Yes.
It could also be an approximation or even a specific case.
Yes, it's aimed to be very general, so it should be consistent with different ways to relate the overarching theories to the previous theories, right? So I guess what you are doing is to suggest a concrete instantiation of how this could work, right? But the overarching theory is just the idea that there should be a way to do that.